Hello, everyone. I am Gabriella Leone. I'm your host today for our Q&A with Michael Munzi, the Vice President of Semiconductors and Electronics here at Siemens Digital Industry Software. We're very excited to have you, Michael, to answer a few questions around your three-pillar strategy, which is a very forward-thinking approach designed to position Siemens as a key enabler of the semiconductors industry growth. Michael is a visionary leader with decades of experience in the semiconductor and electronics industry, and he is here to share his unique perspective on the challenges and opportunities facing the industry today. So, Michael, thank you for joining us today, and let's jump right into our first question. You have developed a three-pillar strategy to address the challenges and opportunities in the semiconductor and electronics industry. Could you give us a high-level overview of what these three pillars are and why you believe this framework is critical for the industry's future?
Sure thing. And actually, let me answer the question in reverse, right? The reason why it's critical for the industry's future is the semiconductor industry has been experiencing, enormous growth over the past few years. And there's predictions that the industry is going to be a $1 trillion industry by 2030. That might actually be conservative because there are many analysts out there saying, due to the growth in need for AI chips for server farms, for all the AI work that's happening right now, we may hit it even before that. But with the industry growing that fast and getting close to $1 trillion, there's quite a few headwinds that the industry faces, namely the complexity of doing advanced node design and the cost of doing advanced node design. And just to give a quick idea on the complexity, if you think about the transistors that go into our integrated circuits, we were using the same transistor for 50 years. It was known as a planar transistor. And eventually we get to a point where that wouldn't work anymore. And we moved into FinFET. And we've had FinFETs for about 10 years now. And they're starting to not work anymore. And now we're looking to new technologies like gate all around. And that may only be around for a couple of years before we have to move to the next one, right? So the innovation and the technology is growing really fast. Associated with that also is the cost to do semiconductor design, that you have a new fab, if you want to build an advanced node fab, costing upwards of $19 billion. If you want to do a new design start, it in excess of $500 million to do a new design start now. So these companies are starting to look at ways to, share the difficulties, share the challenges, share the cost. And we're starting to see changing business models, and we're starting to see the need for companies to collaborate, not only within their own companies, but also within the ecosystem and even outside of the ecosystem. So going back to like the three pillars are really focused in on what's changing, what needs to be enabled. The first one being all about collaboration and building a platform where companies can collaborate within their changing business models, collaborate with the need to work within the industries and even across industries to be able to make this happen. The second pillar is all about software-defined product. Every product that we use right now has some amount of software in it, and the software actually defines the user interface, it defines our experience, and therefore the fact that software now is so prevalent, it's changing the way that we do designs, and we need to account for that and be able to support the software-defined product and the changes and the evolutions that are going to happen to our design methodologies. And this all ties into, the third pillar, which is we do a very good job in the industry of creating a digital twin of the design. In fact, that's the way we've always done semiconductor design. We've done it virtually. But we ramp new processes and we ramp new designs in the fabs themselves real time. And that becomes very costly and time consuming. And with advanced node chips taking longer and longer to actually manufacture in the fabs, it only means the ramp time for these new products and these new process nodes is getting longer. So we really need to start to look at what it means to create a digital twin of not just design, but design and manufacturing together So we could start doing a lot more optimization and ramping of designs and processes virtually to save on the amount of time it takes and certainly save on the cost of ramping a new design as well.
That makes a lot of sense. Thank you for explaining the three pillars. Uh, let's focus on the first pillar, which centers around creating a collaborative semiconductor business platform, which you had mentioned the word collaboration as being part of the first pillar. You also mentioned rising costs in the billions. So, can you explain a little bit in depth what the platform is, why collaboration, both within companies and across industries, is so essential in today's semiconductor landscape. But then additionally, could you get a little bit into these changes and cost changes and partnerships that are forming across the industries and how the first pillar will address the challenges and problems that companies may have?
Absolutely. Let's take for example a company like Intel. Intel's been around for a very long time, and Intel's what we call an IDM or integrated device manufacturer, meaning that they do not only design but they also manufacture their chip. This is different from what we call a fabless customer, where the fabless customer does the design but then outsources the manufacturing to a third party to actually manufacture the chips. So in looking at, a company like Intel and the fact that again, the costs are so high in building new fabs and the costs with developing the new advanced nodes are so high that they're realizing that they need to compete in a different way. And what they are doing right now is actually spinning off the fabrication side of their business and opening it up to be a not only a fab for themselves, but also a fab for third parties. So now this is a case of where um, the way, if you're in Intel, the way you've interacted before, where you have a dedicated fab, it's going to change because you're going to have a fab now that is also going to be manufacturing other people's designs. And it's going to be very similar to the fabless model, where you're going to have to schedule your manufacturing in a way that you're going to be needing to fit it into other manufacturing that the fab might be doing for other companies. And that's going to just immediately now change the way that you do business as a designer inside of Intel and being able to actually understand when the parts can be manufactured and when you start to get parts back, right? So it's just changing the whole model internally, which means the way the design teams are going to have to work with the manufacturing team, this would be very different because it's not a captive manufacturing plant for them to use. It's going to be very much as if they were going to a third party also. And then, in the future, Intel may entirely spin off it as an independent company as well, and it will become an independent fab. And Intel's going to have to adapt to that. So it's really about now, what does it mean now to really have to coordinate the way you do design and hand off design to manufacturing and hand it off in a way that, those parts are manufactured and get the information back, not only on what's happening in manufacturing and how to do better design, to manufacture better parts, but also to understand when you're going to get volumes of parts back from the fab.
Okay, thank you for that explanation. I think Intel is a great example. And maybe sticking with Intel, or if you'd like to discuss another company, can you share some examples of how your platform and Siemens in general would enable or enhance these kinds of new partnerships that companies will have to collaborate together?
Absolutely, absolutely. And another good example is Analog Devices. Analog Devices is also an IDM, been around for a very long time. Um, they're also challenged with the cost of building new fabs, and um, they really do not want to make the capital investment in developing these new advanced node fabs. So they just signed a MOU with Tata Electronics over in India. Tata Electronics is actually building fabs, and they're doing this because of a large capital investment coming from the Indian government, and all part of what we're seeing around the world right now of the onshoring or semiconductor manufacturing. So in this way, that for their advanced node design, they're now going to be able to work with Tata Electronics to be able to build their advanced manufacture advanced node design. Part of the agreement also, crosses over into another division of Tata, which is Tata Motors, which is makes automobiles. Tata Motors needs ECUs, the controlling elements of the semiconductors inside cars.
Okay.
Analog Devices actually has a division that does ECU. So they're going to look to Analog Devices to develop and design the ECUs for them to use. So now you're seeing a case again from a collaborative point of view of, sharing the cost and the challenges of Analog Devices working with Tata Electronics, but also Tata Motors working with Analog Devices for actual ECU development. So you're going to need a way to be able to collaborate again across different companies in this case. And, again, similar to what I said with Intel, where Intel is going to have to figure out how to collaborate with a fab that's also manufacturing other parts. That's part of what's going to have to happen. But you also have development collaboration where you have Tata Motors supplying requirement to Analog Devices for what they need to do, and in terms of what types of functions they have to provide, what type of software they have to run. And you have to make sure there's tight collaboration between those two companies to be able to be successful doing this as well. So now this is a case of, collaboration within the industry across different companies that's going to happen for things to work well moving forward.
That makes sense. Thank you for that explanation as well. Something that you brought up a few times already in this conversation is a lot of government spending towards chips and towards the manufacturing of semiconductors. Why do you think there's such a ramp up with all these different countries putting so much spending onto semiconductors? Is it a race to be first, or is it more to the first pillar of everyone getting on board and ramping up their technology so that there can be more collaboration?
Well, I think first and foremost, it's the fact that those semiconductors are critical to almost everything that we do today. And we saw during COVID that when there were supply chain problems, it affected, us being able to get products, because inside all the products are the semiconductors that are running the software that are driving these different products. So people now realize that having a strong and secure supply chain, a semiconductor part, is really, really important. So I think first and foremost, it's really about guaranteeing access to the technology so that you don't have supply chain blips that you've had before. In terms of being, first something, there are certain companies that are are ahead in terms of technology than other companies right now. When you look at companies like TSMC and Samsung, which are the leaders in the advanced node designs right now, companies will still continue to collaborate with those other companies and use them to manufacture parts. And there's still going to be, cross country cooperation in these areas. And over time, you'll have other companies catching up. It's not going to happen overnight. Um, it's not even going to happen in the short term in terms of number of years. That eventually is going to happen. And I think that's going to be more of a byproduct of the onshoring of it, just for the supply chain point of view.
Okay, that makes sense as well. I'd like to switch the conversation a little bit and talk more about the role of data and metrics in collaboration, because a big part of your first pillar seems to be about leveraging real time data and metrics to improve decision making. How does this work in practice, and what kind of impact do you see this having on project timelines and outcomes down the road?
Yeah. So the interesting thing is that the the, the development of a semiconductor is done with the tools known as EDA tools, and um, they're critical. They're what allow companies to design and verify all semiconductor development before it's ever handed off to be manufactured. Here's the interesting thing: they produce tons and tons of data, and this data is, could be used to understand where you are from a schedule point of view, understand where there's potential problems, understand historical trends over time, to understand the time it actually takes to get something done. But if you mine the data in the right way, um, as advanced from a technology point of view, semiconductors are, a lot of semiconductor development, the way it's managed, the way schedules are managed, and program management is done, it's still done in a old way, whether it's done in PowerPoint presentations, Excel spreadsheets, um, requiring the engineers to roll up a bunch of data, which then gets rolled up into an overall spreadsheet to track where you are right now. That's the way it's always been done, but it has never really worked well. And now with the size of the designs and the complexity of the designs, it's going to get to the point where it's not going to be able to be used at all. This is where like real time data and metrics come into play. Then if you're able to harvest all of this data about the development process and not just from a design point of view, but also from a manufacturing point of view, you could start leveraging that data and using it to track where you are in your design, where you're having difficulties, where certain parts of the design may be stuck. And that's going to help a lot in terms of, managing the project day to day. But then when you look at it across design into manufacturing as well, you could now start, you know, understanding how design decisions affect manufacturability and the ramp to yield and the ramp to the number of parts that you need over time. And then likewise, you could start also understanding what's going on in the manufacturing process and how certain design decisions have affected things in manufacturing, and then feed that back to produce better libraries and better methodologies going forward. So we're now at the ability, I think we're now at the point where we have the ability to do this, but we need to actually start utilizing all of this data and all the metrics we have throughout the design and manufacturing process and using them to start to automate the way we actually manage our semiconductor businesses.
Okay. That also makes a lot of sense and gives a lot of insight into how things can work in the future. That being said, we've talked about the data and metrics, the need for collaboration, rising high costs, and you've also given some great examples of some companies that are already starting to implement the idea around collaboration. But what about some of the companies that might be resistant to collaboration? The semiconductor industry is known for being highly secretive. How do you envision overcoming this cultural resistance to sharing data and collaborating more openly? And what steps is Siemens going to be taking to build trust and encourage adoption of this platform?
Yeah, yeah, absolutely. This has always been a industry where data's been kept really, really secret. And quite frankly, you can understand why, because um, any leak of any of the IP could quickly allow a competitor to duplicate designs and functionality or manufacturing processes. And that's been the core reason why it's been such a secretive industry. But again, we're starting to get to that point where things are going to have to change again, from going back to the cost reason and the complexity reason I talked about earlier. If a fab is going to invest $19 billion, they're going to want to make sure that they're fully utilized in producing producing semiconductors for their customers, because that's how they're going to get paid. and they're not going to be able to deal with the long ramp times for process nodes. There's a long ramp time for new designs that they come into the fab. So there's going to be some pressure starting to be put on not only the design companies, but the fabs and the semiconductor equipment manufacturers to start opening up a little bit and be more collaborative across the whole ecosystem, because there the, it's going to be untenable without um, some changes happening. And of course, things are done in the right way with the right security along the way, and understanding what information needs to be shared versus what information doesn't need to be shared, and understanding this, then we could start to get to a point where we're going to start seeing things opening up a little bit more and allowing for some sharing of data and exchange of data just to make the entire ecosystem run better.
That makes sense as well. It sounds like if you don't collaborate into the future of the industry, you might get a little bit left behind or put your business at risk for not being able to provide at the same pace as other companies that are open to collaboration.